Good morning, Krakow. Morning. Hey, it's great to see so many people here. Hands up who's recovering from last night still, the free bar? Me, a little bit. I'm really excited to be here today to talk to you about monoliths and microservices, specifically the journey from monolith to a microservice app. Who am I? Well, my name's Callum Whyte. I'm from the UK. I'm on Twitter. I tweet quite a lot. I'm a .NET developer by trade, and I've worked in digital agencies for most of my career, working with a .NET CMS called Umbraco. But I've recently started as a consultant. I do .NET architecture, Azure, and a bunch of other stuff. I'm really lucky I get to travel all over the world, including places like this, and speak at events. I also organize a few events, including my own conference in London. I also really love donuts. So whenever someone hears the word microservices, I think a lot of these terms come up. So I'm going to categorically say now this session is not about Docker, it's not about Kubernetes, and actually it's not even necessarily best practice. All I'm doing is I'm going to share my story, my journey of taking this horrible application and making it into elegant microservices. And a big disclaimer is the team that I was working with, we kind of made this up as we went along. So your experience might vary, and I would love to hear about it afterwards. But what actually are we going to talk about? So iteratively improving a really badly written application. Some of the patterns that maybe you could go away and use to follow the similar approach. The journey that my team took to building a maintainable solution, maintainable application, what we learned along the way, and what we're going to do to make it less shit in future. I hope that whilst I'm going to be using examples that are grounded in .NET and using Azure, actually these principles apply to any tech stack that you're using, if it's Java or Go or even Docker and Kubernetes. I'd also quite like to just touch on how our process as a team changed towards the end of the talk, because this was our first ever time implementing a microservice application. So here's the story. I was working for a digital agency in London. We have an office in London and also here in Krakow. We would generally build websites on .NET Framework. Because of that, we're kind of used to dealing with marketing departments and getting campaigns out of the door quickly, but we hadn't really had much experience building a product. For us, we would perform a change, we would push that to the client's environment to test, they'd sign off, and we'd go ahead and release that. The whole project here, in this case Hampton Medical, came about because a friend, one of the directors of the company, said, I have this app. I've paid a company in Lithuania 7,000 British pounds, and they have built me this mobile app. The mobile app has a native app for both iOS and for Android, built in Java and Swift. It has an Angular JS, like as in old Angular JS, web portal that doctors can log in and interact with our system. And the back end is written in .NET. It's .NET Framework with a SQL database. This was the kind of stuff we were used to dealing with, so not necessarily a huge shock. The principle of the app is that during pregnancy, women with high blood pressure need to record a regular blood pressure reading and also perhaps take a urine sample and deliver those results to a doctor. Traditionally, in the UK, one of these patients would phone up their doctor's surgery daily and say, here is my readings for today. And if there was anything that was an issue, they would be asked to come into the doctor's surgery. This takes a lot of time and costs the NHS actually a lot of money, because you have to have someone physically there answering the phone and responding and acting. Now, the goal of this app was to kind of digitize that, to fix it, save the NHS a bunch of money. In fact, it costs only a third of the cost of doing this in real life. So a patient would have the app, they'd log in, they'd register their readings. If there was an issue, they'd be instantly notified to contact their doctor, and their doctor would instantly be notified too. So, this app was put together in a couple of months by this Lithuanian company. And then we get a message saying, we need some help. We're not really making the progress we want. We need to launch this in every hospital in the UK by Christmas. We need you to improve the UI, fix a couple of bugs for us, and we actually have no way of charging people, hospitals, to use this app right now. This was October. Because we were a digital agency and kind of used to saying yes to everything, we went, yeah, sure, we can do that. How hard can it be? I think a lot of people in this room may have been in this situation with their team, where they've kind of agreed to something, perhaps a little bit blindly, without really knowing too much about it, and found themselves in at the deep end. So when inheriting a code base, we were handed over the code from this company in Lithuania. We first started by familiarizing ourselves with the logic. Actually, we hadn't built this thing. We didn't know how it all worked or hung together. We had a little look at some of the patterns that they were using because we wanted to try and maintain the code base in a relatively consistent way. And the key was we actually had to come up with something that meant we were going to understand it and were going to be able to work on it in future. We also noted any questions, areas of concern, fed those back to the original developers to try and get some insight, and also to the product owner, the client. I spent a few days digging deeper into this code base, taking a little look, and it was a mess, a real mess. Spaghetti code everywhere, humongous blocks of code that was very difficult to understand. Huge, glaring bugs, and some massive security issues too. So this native mobile app that I mentioned actually wasn't really native at all. On iOS, it was a login page that had been coded into the app, and the rest of the app was literally just a web view, an iframe, if you will, looking at a responsive website. So it wasn't an app at all, it was a website. The Android app was just the web view. And we found that actually between the two, things have been implemented in different ways. The API was absolutely impossible to understand, and the Visual Studio solution, it didn't build. I mentioned this had to roll out to every or a large number of NHS hospitals. It was running at that stage on a free tier AWS Windows server. So definitely wasn't going to have the power to scale up to tens, thousands of users. The code base that we were actually given hadn't been updated in 6 months. It wasn't what was on production. I had to decompile DLLs and confirm it definitely wasn't what was on production. It actually took me 3 weeks to get all of the changes merged together and working before we could even start work. We're very quickly eating into our, we have to get this live by Christmas timeframe. I'm actually going to show you some code because I think it's quite funny to look at. Even if you don't understand C#, I kind of hope that this will make sense. So we got given a project. Is that zoomed enough for people? Cool. We got given a project that had an API, a front end, some models, some schedule stuff, some services. Turns out this scheduler didn't do anything. The MVC app that lives here actually wasn't used at all, was never deployed. The models, there is a hell of a lot of models, and we can just have a little look at some of them. Where was it? Account, like some really complex models with a bit of logic in them. But that's actually not the worst of it. When we look at the API and go into the controllers, let's just take, say, the account controller. That's the number of using statements. This is the number of references being pulled in. That's 52 lines of code. We have a few thousand lines of code in here doing who knows what. And this is the case across every single one of the files. So the document controller, the history controller, whoa. There is tens of thousands of lines of code in this project, and actually we couldn't make any sense of it. Some of these API endpoints weren't used in the website. Many of them, the code didn't really make much sense. You don't have to look too far to realize they're doing all of their entity framework work, kind of pulling the queries together directly in the controllers, and it's all inside if statements, and it's just really, really inconsistent. Very difficult to understand. So we had a load of unknowns. We didn't really know how the project worked. We didn't know directly the business requirements, and we had a whole bunch of code that we probably couldn't maintain too easily. We'd only just got it building, let alone did we know for sure that it was what was actually on production. All of this together meant we had a ball of crap that we didn't really know what to do with. We're going to call this the monolithic monster. Where do we go from here? This is a bad situation. We've kind of committed to delivering on this, and we have people relying on us. It's not just another client, it's also a friend of the company. We realized we kind of needed to start over. And this wasn't going to happen in the time frame that we wanted, and was definitely going to cost too much. But our kick-ass design team got to work, and they conceptualized how this app could and should look and work in future, kind of meeting all of the new requirements we've been given. It looks a hell of a lot nicer. It's a really, really slick, nice app with a nice back end for the doctors and clinicians to log into. But we had to do something about this code base. Now, we couldn't really justify just rewriting it. We didn't have time, we didn't have resource. It's too costly, at least for now. The app itself needed to get out there and start making money before we could justify that. But it's way too risky to maintain in its current state. You saw that. I mean, if I was tasked with fixing a bug in that code, who would know where to start looking for it? So we came up with an approach. Whether this was right or wrong, I don't know. We decided we would reskin the existing AngularJS app. Actually, when I looked into the AngularJS code, despite being a bit outdated, it was pretty well written. It worked quite well. There was a few front-end bugs we had to fix, but actually one of our front-end developers managed to reskin it and fix all of those in a week. So we were winning in some ways. The mobile apps that we had, those native-ish apps that were just looking at the website, well, those would all automatically take on that new design, but we needed to update some UI components. Now, we were a .NET house. We don't do mobile apps, generally. So we decided the best thing here was to rebuild both of those apps in a platform that we understood, which, in our case, was Xamarin. Xamarin is a .NET tool for building cross-platform applications, such as mobile apps. It meant we could implement the new design. This was a bit of a learning curve for us, but a way smaller learning curve than learning iOS and learning Android. We actually migrated their infrastructure over to Azure. The reason being, we were familiar with it. A lot of this was about familiarity. We needed to be in a position to actively support the product. Also, we kind of wanted to use some other tools in future, but I'll come to that. We decided that we had to live with the API in its current state. We were just going to have to deal with it, and as quickly as we possibly could, rewrite the bits that were of concern. This is where this term, the Strangler pattern, comes in. Has anyone heard of this term before? I believe it was coined by Martin Fowler on a blog post from maybe 2003, 2004. It's not an old concept. The idea here is that you would iteratively replace code in your application by strangling it. So that would be when you come to add a new feature, you don't add it to the code base, you add it somewhere alongside, and you're slowly rebuilding that application kind of over here. It avoids this concept of you going away, rewriting an application, and suddenly switching that over to the new version of the app. And things might go quite wrong when you start using something in production or at that kind of level of traffic. There's two concepts. The key concepts are event capture and asset capture. The idea of an event capture is if your application surfaces events, you can hook into those and say, when that happens, run this bit of code. Asset capture would be, I have an API point or a web page, and when someone hits that, instead of going to the application it did before, I'm going to reroute that to somewhere else, and my new application is going to take over. We started replacing the API. Now, it's a hugely complicated application, and the way it had been architected meant that it was pretty difficult for us to work out how it all hung together. So we spent about a week literally mapping out every interaction in the system, every single behavior, the roles of our users, notifications they should receive. This was purely to gain an understanding of how the app actually works. Without this, it would have been really difficult to bug fix. It would have also been really difficult to know what we were replacing. This is just two different sections of the app. If you imagine a meeting room that's kind of a conference room, every wall was covered in these Post-it notes. A lovely project manager went away and had the task of digitizing this and making it a document that everyone could go back and reference. I don't envy their job. The key components of the system we kind of were able to group in some broad umbrellas. Authentication being login, registration, profiles, roles, permissions, doctors, patients, admins. Subscriptions was something new we had to add. We didn't actually have this yet, but they needed a way of knowing this person has the rights to do this and has paid their bill. Consent, because we're dealing with medical data here, we had, we needed to make sure that people were opting into the latest terms and conditions, were optionally saying, I'll have my data used in research. Results, so people actually giving their readings. This was the most critical part of the whole application. If someone's result doesn't get through and it's maybe a misleading or it's a critical issue and the doctor doesn't get notified, that's potentially that patient's life on the line. So this was our most critical part. The alerting as well, making sure that people are notified. Administering the application, creating patients and hospitals. And one of the most important things is logging here, because we didn't know how the hell this app hang together. We decided to focus on 3 areas as our kind of first sweep, and this was based off the initial code review. So we discovered that the authentication that they were using was just really inflexible and didn't allow us to do some of the more advanced things we wanted, like adding subscriptions in future. Also, authentication kind of underpins the whole API. You need a decent permissions model to be able to say, when I go to this API endpoint or this part of the app, do I have permission to see this? It just wasn't implemented very well, so we needed to relook at that. Logging and reporting, we discovered every single interaction in the app was being logged. That's amazing. But it was being logged to some massive SQL database table and causing humongous performance bottlenecks, as you can probably imagine. We decided this needed to be offloaded away from the application. It's not really related to the function of the app. It's more of a thing that happens on the side. So yeah, we had to do something about that. And alerting. We needed to make sure that those alerts to doctors are getting through. Our tests found that the results were kind of working pretty well, so we should focus maybe more on notifying people in a better way than it was currently being implemented. We had to come up with a way of strangling these resources. Now, we decided that we were going to follow a microservice architecture for a couple of reasons. Not only was this going to be used in the NHS, but the goal was in future to roll this out to other countries. With all kinds of medical environments, different countries have different rules, and we needed to make sure that certain people's data could be separated. America is a fantastic example where they have private clinics that want to have this system themselves, but other hospitals in America might also want to have this system. That data has to be kept separate. So we decided that separating all of our distinct components of the application longer term would be the way to go. It also meant we could scale as we needed and work quite nicely. We had never built an app like this before, so we had to come up with a process for working this way. We decided to separate our physical resources, so that would be the code base for one specific service has its own Git repository, its own Visual Studio solution, its own continuous integration process, its own database, its own service bus, queue, topic, its own resources on our hosting. We didn't want to have to manage infrastructure here. We were a relatively small team, so we decided we needed to go for some kind of platform as a service solution with hosted service bus, hosted database. It keeps the costs kind of low, means we can scale pretty easily, and I mentioned that key of being able to deploy stuff in other regions when we need it. This was made really easy. We concluded that we had to just treat our monolith, this ball of crap API that we had, as one of the services. It's a humongous service, but it just has to sit there. It is a component in our application. And finally, how many people in here can, hand on heart, say they unit test everything they write where necessary? Okay, a couple of hands. It's not common practice for people to unit test, sadly, but it should be. And especially with something this critical, where we didn't really understand the logic, we absolutely needed to have full faith in our tests. So we were going to create a test for absolutely everything new that we wrote. This was kind of around the time that Azure Functions 1 came about. It was a pretty new technology. In fact, we were doing stuff that would then was in preview and then would change 2 or 3 days later, and it was quite frustrating. But it was a really, really convenient tool for us. For those that don't know, Azure Functions is as a kind of functions as a service tool. It only executes your code when it's requested. It's very similar to AWS Lambda or Google Cloud Functions or Netlify Functions. There's a whole bunch of these services. ASOS, Domino's Pizza, Have I Been Pwned, all use this service to power their backends. Functions can be triggered in a variety of ways, such as with an HTTP request, like a web API, through something being added to some storage somewhere, an event being triggered or added to a service bus, timers, a whole bunch more different triggers. This fitted really nicely with what we were after, because we had a bunch of different things that it needed to be watching for. Because we're .NET developers, we love the fact that we can write just a C# class with an attribute on it, and that can run as a function. We don't have to know anything special about Azure necessarily, more just focus on the logic that we're actually needing to implement and write. In some places, we could pretty much copy and paste code from the old really bad API into an Azure function, and it would just run, which is really cool. So we had to build some of these other services. We started with the alert service. It was perhaps the most complicated. It had a lot of moving parts. We had emails that needed to be sent, SMS notifications, and in the future, the scope to add push notifications and some other things. We couldn't do this within our old app because the code that triggers these events was scattered everywhere. So we modified our legacy monolith to just say, hey, that method where you're logging everything to the database, stop doing that. Instead, just put everything you're logging onto a service bus, onto a queue. And that way, we can at least try and pick up the changes that we want from the queue. We used an Azure function to then watch that service bus for data coming in. And when we saw the thing that we wanted, we would execute our code. This meant we didn't have to write a huge amount of logic to say, when this happens, do this. It was all the data was all kind of there. We were just waiting for something in order to run. So this is a really nice way of adding something along the side. I mentioned the events before as part of Strangler pattern, but what actually about this asset capture? How do we strangle pieces of functionality that already exist rather than building something new alongside? Well, again, we can push stuff up to a service bus, and that works pretty nicely. We did exactly this for our authentication. So every time an authentication request came in, we chucked some data onto onto a service bus and said, hey, we're looking to authenticate you. And to do this, we would then have a consumer somewhere ready to take all that data and go, does this user exist? Do I need to reformat that model I've been given to work with my new service, for example? We use the authentication service as our guinea pig here because it was pretty critical for the whole application and underpins pretty much everything. We used Identity Server, written in .NET Core, and split this across 3 different services, so we could have an authentication, profiles, and users. This is a bit of a change from what we had before, where we had one big database of just all user data. This meant we could finally start separating stuff out. We put it on Azure Web Apps, and we were then able to just call that whenever we needed to authenticate a user. This was an interesting challenge because we suddenly had to start designing things that we'd never done before, like authentication models, proper authentication models. We used JOT tokens, JWT tokens, as a way of passing some settings around. This was our method for actually handling things like what permissions does this user have. It meant that our existing API didn't really understand what permissions a user had from there. So we had to build some kind of wrapper around our whole API to say, we've got to convert this token to something our API actually understands. To do that, we had to hijack all of those API endpoints that we had. So we needed some kind of proxy tool to sit in between our API that would shove our authentication layer in there and say, this user is this, and let the old API know exactly what that is. Then here we kind of were able to bake in this requirement of if this user is from this country or from this market or in this role, they should be served data from this country, and kind of build some data sovereignty into our application, which is cool. So we had the discussion of, could we just build a .NET API and wrap our other API around that? Some kind of service that sits in front of it, build our own proxy, which seems like a massive mistake because effectively we're just building another monolith here. We're building a service that sits across other services and calls our other services. It just doesn't really make much sense. So this is where we started looking at something like gateways, some off-the-shelf solutions that would let us do this. An API gateway allows us to configure endpoints and say, here's what needs to happen when this endpoint gets called. We can write our own logic inside the gateway to say, do this routing rule if this user's in this market, send them here. And we could then use this to say, you've hit this endpoint, it goes to a new API that we've created, or it goes to our old legacy API. And we can slide our authentication in the middle. So this is kind of how it would look. The web app or the mobile app would call our API gateway. This is on Azure API management. It would then call off to our authentication service for every single request. It would validate that that's the request we want. And then, when it's ready, we would route that request to the different microservices. This was cool because, we didn't really have to do anything to strangle our API endpoints. When it comes to adding a new one, it's an extra line in the config. The authentication service automatically gets called. We can automatically validate, work quite nicely. And here, one of these services would, of course, be our legacy monolith app. So very slowly, we can just take chunks off that, add them as new services. After 6 to 8 weeks of work, we built this authentication service. We'd added our experimental, let's just push all the events onto a queue and wait to see what happens. We thought we were ready for launch. We did some internal testing. We had our new version of the app. It worked pretty nicely. Of course, we screwed up. I think that was pretty predictable. We didn't really know some of the dangers, risks of running a system like this, a distributed system. We had issues where people would change domain models, and therefore the objects that were being put on the queue would then be different. And then our consumer apps that were expecting certain data there, the data wouldn't be there. And then they would crash or they wouldn't run. And then diagnosing all of those issues is also a huge pain in the ass. It's a bit of fun. We encountered some quirks with Azure. I mentioned this was kind of earlier on in the Azure functions days, but triggers not firing. So let's say a timer that's supposed to run every day at 9 a.m. to send some emails out to doctors saying, here's what happened yesterday. Well, they weren't firing. And every time we tested them, they would work absolutely fine. It turns out Azure resources were going to sleep overnight, and they would need someone to come in and manually wake them up. And it's because we'd put them on a consumption plan where they would not be running constantly. You kind of have to make sure that all the critical parts of your system are up at all times, or at least all the parts of your system are up at all times. I think one of our biggest ones was validating inputs. I mentioned that we abstracted the authentication away, and the app no longer knew who, our old monolith no longer knew who was talking to it, but we had to work out our permissions somehow. So making sure that if someone hits the API, we check that they've got permissions to hit that endpoint. That's great. But do we then also do the check when we try and store the data? We probably should, because we have no real idea of how all of this hangs together. It got a bit clumsy, and we ended up writing like libraries that would validate inputs and use those in both places, and it creates a bit of a mess. To this day, I still don't really know what the answer is. I think we probably should be validating as many times as we can. But when a service calls 3 other services, having to validate the same data over and over becomes, clumsy. A quick summary of what we've actually achieved there. So we took a really badly architected application, a monolith. The code was impossible to understand. We investigated it, found our pain points, found the bits that we weren't happy with, which was authentication, logging, alerting. And we identified the key components we wanted to rewrite or get rid of, and kind of a priority on those, so authentication being pretty high up. The microservice architecture was chosen because it gave us the ability to rewrite stuff incrementally. We didn't have this big bang launch where we would go, hey, here's your new app, and it wouldn't work. And also that perhaps this was good for us scaling in future. We were able to strangle our mobile app kind of without realizing it, because we decided to rewrite it in a completely new technology and swap those out for this tech that we understood, Xamarin. Our monolith was also kept inside the app as one of our services, and again, we can slowly strangle that, chip away at it over time. The functions we used to build things like the alert service, and we tied all of that together with our monolith using Azure Service Bus, pushing data between. But we needed to make sure we validate our models. And slowly we replaced services with the Azure API gateway, so when an API endpoint got hit, it would call off to our new one or our old service. Authentication was rewritten. That was kind of called as part of all of that. Now, this happened very, very quickly. We didn't really have any knowledge of microservices going into this, and it was an interesting outcome. I mentioned at the start, we were a digital agency, used to building marketing sites, campaigns for clients. There was a pretty steep technical learning curve, which was a challenge. Xamarin wasn't too difficult to get our head around. Neither were Azure Functions, an API gateway, but this concept of having the application distributed was tough. And when you bring on new developers, we were scaling up at kind of a developer a week on this team just to get it over the line. Explaining that's pretty tough. We had to redefine our processes for the project and explain to everyone coming on to the project that the life cycle of this is very different. We don't do a change, send it to the client to test. We kind of have to get more used to deploying something as soon as it's ready, get it out there, do more incremental changes, test multiple times a day for different scenarios, that sort of thing. And I mean, our process was normally dev, staging, live. We didn't have that. So explaining to internal people what state a project was in, saying it's being tested, and saying, well, you can't really see that it's being tested, it's just an API, was an interesting challenge. One of the things I did when onboarding new developers to the team was recommend that they spend their first day reading this blog post series. Now, that might sound a bit odd, but there's a blog post series called a microservice implementation journey. It's a 8 or 10-part series, and I highly recommend reading it. Even if you're using microservices already, it's a lot of the truths and the frustrations that everyone experiences, and kind of some solutions to get around them, but also admitting that there is no perfect solution to some of these things, and just discussing the possible outcomes. This really helped getting our team on board with understanding exactly how all of this application we were going to build was going to work. On the plus side, structuring ourselves like this meant we could work a bit faster. We were able to have independent people working on independent parts of the application without really worrying too much about each other or what they were doing. It meant no treading on toes. So if my colleague Joe is going to go and build the authentication service and I'm building alerting, we don't really get in each other's way. If we're on the same code base, we're probably going to end up with merge conflicts, and it's going to be really horrible. Our documentation actually got better for our projects. Traditionally, as a company, we wouldn't document anything, and that's not great. This, because it was so complicated and a lot of people didn't really understand it, we had to document properly. And my job and the project manager's job was effectively making sure everything was documented and clear. It really meant that we could onboard people far quicker. And the best thing about all of this microservice stuff is we got to choose the languages that work best for us. So we discussed doing some machine learning on data in the future. We could use Python for that. We wouldn't be stuck into we're using .NET for the API, we have to do it this way. Similarly, we'd never really used functions before, but functions seemed like the sensible thing to be using because of the nature of the application, so we could use functions. A quick example of some of our documentation, actually. We explained a lot of our concepts visually to the team, because presenting a big document and saying, read this and you might understand, just isn't too friendly. So we'd have our dev server, our staging, and our pre-prod and production versions of our applications, and we kind of married up that to an app, a physical app that someone could interact with, so at least they'd be able to see and feel roughly what state a project was in when we used certain terminology. And this helped translate from our old internal process for client websites to this product process that we would use with this project. Just made things a lot easier. And I think this kind of visual documentation is far more effective, makes far more sense than a huge document. I mentioned this microservice implementation journey. Highly recommend reading that. Please go away and read that. I also recommended that everyone goes away and reads JSend, which is a pretty simple spec for API responses. We just had to be talking the same language within the team, and so saying, hey, this is what we're going to be returning from our APIs, everyone sort of got it. Martin Fowler has his blog on Strangler patterns, Strangler applications. There's a link there. Again, highly recommend reading that because it sort of explains a lot of this in a bit more detail. And Microsoft have a good one too, which does start to go into some of the concepts I've discussed using Azure resources as part of this way of containing your application. That was me. That was my quick story about how we moved our application from this horrible code base progressively over to this new .NET Azure Functions, Azure Cloud Native-ish application. thank you for listening, and I'll be around for any questions. Do we want to take some questions now? I mean, we've got 9 minutes. Go. Yeah. So the question was, did we run into any problems, issues with testing, integration testing stuff that affects maybe multiple services, and how that would affect the service bus? How that works with service bus. Yes, we did, and we came up against a really nice problem here, where we had multiple people working on the same, the two different projects, but that would talk to the same service bus. And their projects would maybe both have triggers in them, and someone would put a message on the service bus, and a trigger would happen in someone's dev environment, and we wouldn't know what was going on. This was pretty early days for the kind of local tools for developing with functions, and it meant that there wasn't a local emulator of a service bus. Nowadays, we would say everyone's local dev environment has their own local service bus, their own local storage, and we ended up creating one big Git repo with submodules of all of the other services. So you could pull that down and run specific versions of specific services in one place. And that way you could kind of isolate all of your changes locally and not randomly trigger events on other people's dev environments. Yeah. Did we have any problems with the call stack? Oh, cold start of functions. Yes, absolutely. They're pretty slow to start up, especially with our APIs. We were pretty lucky that during the development cycle of this, Azure actually introduced their always-on feature. So we were able to deploy a function. We would version the function name. So every service would then have authentication service -v1 or whatever. And it meant that we could spin up a deployment, get it warmed up, ready, and then swap it out in our API gateway so no one ever saw the start time being really slow. When we were using the consumption tier, they would power down overnight. People would generally do their data at midnight and maybe 6 a.m., but not between those times. And so in the day, they would fall asleep. And it meant that a few people waited 2 minutes for their reading to actually go through. By nowadays, you can say, I want this always on, and it kind of gets around that problem. Yeah, at the back. Cool. So the question was, how did we debug our various applications and what was going on? So the events were pushed to a service bus, and when we took them off the queue, we put them onto a kind of dead queue so that we could reprocess that later if something had gone wrong. And it gave us up to 7 days worth of visibility of what had actually happened in our application. But to add to that, we pretty aggressively used Azure App Insights and logged as much as we possibly could there, especially when stuff went wrong, just because then we could say, yeah, we can pinpoint this exact time where an error happened. Especially when you're dealing with medical data, we actually decided we needed to log every request that came in anyway, just in case we had missed something and failed to process it. The way we did this was application gateway, API gateway, lets you do that, and you can log to blob storage. Because we were dealing with medical data, we didn't just want that sitting around on a blob storage. So we actually had a process that would encrypt those files and put them on blob storage, and we kept those for 3 months. So if we did have something at a specific time that had gone wrong, we could go back, find the log file for that exact point in time, see what request came into us, and see maybe where we screwed up with processing it. we've got time for one more question. Okay, if there's nothing more, I thank you again for listening, and I'll see you around the conference.